So good morning everyone and welcome to this lecture. This is lecture number 4 and we are going to deal with Kirchhoff's law. Probably we'll be starting with it and most probably end the same in this class today. Before going on to that, in the previous class we had seen the series parallel combination of capacitors. Now on that series parallel combination of capacitors, we had seen how to find out the effective capacitance and other things. We can also use that series parallel combination to solve circuit problems and finding out currents and voltages and charges on the capacitors and the resistors. How you got to do it? So let us start with this circuit of one battery or cell. There's only one battery or one cell in the entire circuit. How are you going to solve that circuit? Now, how are you going to solve that circuit? You just can solve the circuit using your series parallel combination. Now, whenever you are trying to solve the circuit using series parallel combination, remember it's all about getting the answers in the fastest possible way. And to get the answer in the fastest possible way, you must remember how does current and charge gets divided in series and parallel combination. So just giving you a recap for a capacitor. If there are two capacitors in series, the total voltage drop is V. The voltage gets distributed in inverse ratio of capacitance. So V1 becomes C2 upon C1 plus C2 into V, and V2 becomes C1 upon C1 plus C2 into V. Do we remember this?
Yes, sir.
Similarly, if there is a charge Q which is getting divided into two parallel branches, charge will get divided in direct ratio of capacitance. So Q1 will be equal to Q into C1 upon C1 plus C2, and Q2 will be equal to Q into C2 upon C1 plus C2. But when we come on to resistances, reverse thing happens. What do I what do you mean by the reversing happening? When they are in series, the voltage divides in direct ratio of resistances. Do we understand this?
Yes, sir.
Voltage divides in direct ratio of their resistances, and current divide in inverse ratio of their resistances. So if current is getting divided into two parallel branches, I1 will be equal to I into R2 divided by R1 plus R2, and I2 will be equal to I into R1 divided by R1 plus R2. Whereas V1 will be equal to R1 into V divided by R1 plus R2. Do we understand this?
Yes, sir.
We remember this. Current divides in inverse ratio of resistances, and voltage divides in direct ratio of resistances. In capacitance it is reversed. Now if in any one of these branches there is no resistance, that means if there is no resistance we call it short circuit. If there is no resistance, that means there is short circuit. What will happen to the current?
Does not flow through that.
So the current will not flow through the upper branch and the entire current will go through the lower branch. Do we understand this?
Yes, sir.
So current divides in direct ratio of resistance, current divide in inverse ratio of resistances, and voltage divides in direct ratio of resistances. This is the first thing that you must remember. And the second thing, you just have to solve uh, solve the, what should I say, circuit using a combination of series and parallel. Let me just give you an example of how you can solve this circuit. Let us say this is a circuit that I have. I'm just making a simple one. This is 3 microfarad, this is 6 microfarad, and this is 4 microfarad, and this battery is having voltage of 10 volts. Now you have to tell me the charge coming on all the three capacitors and the potential drop. I mean, once you get the value of charge or once you get the value of potential drop, the entire question is solved. They can ask you what is the charge on the capacitor. They can ask you what is the potential drop across each capacitor. They can ask you what is the energy stored in any of the capacitor. No matter what happens, the question remains the same. You have to solve the circuit and get the answer. How are you going to solve this? I'll give you 2 minutes to think about it. So how are you going to solve this question? This is a very straightforward, simple question. There are many ways to solve this. Way is only one, but you can still solve it. This 3 microfarad capacitor and this 6 microfarad capacitor, how are they connected?
Series, there is 2 mu f
They are
on
connected in series, so the effective capacitance becomes 2 mu f. Now, as soon as you get that answer that the effective capacitance is 2 mu farad, you don't have to go any further. Remember, you have to solve the question in the quickest possible way. The combination now looks like this. Now, this question is pretty damn simple. Both the capacitors, whether this is this 4 microfarad capacitor or whether it is this 2 microfarad capacitor, they are both connected in parallel across the 10 volt battery. So straight away you can find out the charge on each of these capacitor. What will be the charge on this capacitor?
20 mu c, sir.
20 microcoulomb. And what will be the charge on this capacitor?
40 mu c.
40 microcoulomb. Straight away you get your answers. Now, as soon as you know the charge on the capacitor is 20 microcoulomb, this capacitor basically consists of two capacitors which were in series. So, charge on each of these capacitors will be how much?
40 by 3 and 20 by 3 mu c, sir. 6 by 9 into 20 and 3 by 9 into 20.
Both these capacitors are in series. So charge is same. So charge on this one will be 20 microcoulomb and charge on this one will be 20 microcoulomb. Same. Capacitors are in series. Once you know that, you can also find the potential drop across each of the capacitors. The potential drop across this capacitor Q is equal to CV is the only formula that you know. So potential drop across this one will be 20 by 3 volt and potential drop across this will be 20 by 6. 20 by 3 and 20 by 6. If you add both of these, you will end up with 10 volts. That is the total potential drop. The potential drop across this capacitor is obviously 10 volt. That is well evident. So, if you remember simple things correctly, you should be able to solve the circuit very fast. Do you understand this?
Yes, sir.
What, sir? Everyone has understood this, what I have done here.
Yes, sir.
Pakka?
Yes, sir.
I'll give you 2 minutes to note it down. Let me know once you are done. Let me move on to the next question, and the next question is like this. Again, anything could be asked. They could ask you what is the charge on each capacitor. They could ask you the potential drop across each capacitor. They could ask you the energy stored in each capacitor. If you could calculate any one of this, you should be able to calculate the other ones. So I'll give you a chance to do it. Let me know once you are done and do it fast. So how are we supposed to do this? These two capacitors, as you can see, they are connected in parallel, so you can remove them and put a single capacitor, 10 volt. This is 3 microfarad. This would be 6 microfarad. Now this 3 and 6, as you can see, they are connected in series. So now you can replace them and the circuit now starts to look
UC,
like
sir.
this. This will be 2 microfarad and this will be 10 volts. Do we understand this?
Yes, sir.
Now once you get this, now you can find out what will be the charge coming on this combination 2 microfarad. What will be the charge coming on this 2
20
microfarad?
20 microcoulombs, sir.
So this will be 20 microcoulombs. Now once you get this, now you can go back to the previous step. Now this 20 microcoulomb capacitor, 2 microfarad capacitor was actually made from 3 and 6. So what are the charges on the 3 and the 6?
20 and 20, sir.
So this will have 20 microcoulomb. This will have also 20 microcoulomb. Yes or no?
Yes, sir.
Now from here you can jump back to this one. This 3 microfarad will have 20 microcoulomb, but this is a parallel combination. So this 20 microcoulomb will get distributed in the parallel combination. Do we understand this?
Yes, sir. Q
So,
on
so
charge
how
on
much charge this will get?
40 by 3 and 20 by 3, sir.
20 into 4 divided by 6. Yes or no?
Yes, sir.
Direct ratio. And this will get 20 into 2 divided by 6. Do we understand this?
Yes, sir.
This is the way you have to do this. Do we understand?
Yes, sir.
This is one way of doing it. The other way of doing this would have been if you go to this step, once you reach this step, then these are two capacitors in series. You can find out the potential drop across each capacitor. It is in the inverse ratio. From that potential drop, you can calculate the charges on each of the capacitor. No matter how you do it, you have to do it quickly. If you can do it quickly enough, you should be able to get the answer fast enough. Do we understand this?
Yes, sir.
Let me see how you do with this question. There are a few questions that has come in recent exams. I think one or two questions have come in this exam also. The papers are there with me, but becomes very difficult for me to see each and every paper and get the questions from there unless they are at one place subject wise. This is 2019 JEE. In the given circuit, what is the charge on the 4 microfarad capacitor? I'll give you 2 minutes to give me the answer. So how are you supposed to do it? This is as simple as it gets. Don't have to even use a copy and a pen. 1 plus 5, how much it becomes? It
6.
becomes 6. Yes or no?
Yes, sir.
You just have to find the charge on this 4 microfarad. 4 and 6. Different ways to do it. Now this 10 volt battery, I will do it in a different way. This 10 volt battery, this is the total potential drop across these two is 10 volt. Yes or no?
Yes, sir.
So across the 4 microfarad, it would be 10 into 6 divided by 10. Yes or no?
Yes, sir.
Inverse ratio. Do you understand inverse ratio?
Yes,
So
sir.
across this, the potential drop is 6 volt. 6 into 4, 24. And 24 is the answer here. Do we understand this?
Yes,
This
sir.
is gone above our head saying bye bye.
Understood, sir.
The questions that come in JEE are pretty straightforward and pretty simple. See, I'm showing you the question from this shift. This is 25 January shift 1. See, they're asking you this question in a JEE. What is the equivalent resistance? What is the equivalent resistance of this?
3R, sir.
See, don't have to use a copy pen. What questions we have done and what questions they are asking. These are the questions from JEE. This one, equivalent resistance. Anyone can get the answer for this. You can't get it?
16/3, sir.
5 is the answer. 16/3. How did you get 16/3? This is shorted. This is shorted. So everything is shorted. So the circuit remains what? Here 1, here 2, here 3, and here 3, here 2. This is the circuit. Everything else is shorted.
Yes, sir. I thought that.
Yeah, you thought think a lot and don't do it properly. Thinking is not good. These are the questions they ask in a JEE. It is no longer JEE. This is more like board exam. Even for a board exam, this question is easy. Because in board exam, you have to write something. Here, you don't have to write anything even. Anyways, let me move ahead and give you this. You will not be able to do. Okay. Now I put this question in this way. What is the current in each circuit, each branch? Whatever. I'll give you 2 minutes to solve this. So how are we supposed to do this? This 3 and this 6 are in parallel. So how much it becomes?
2, sir.
This gentleman becomes 2. So take them off and just put 2. Any kid can do this. 12 volt. Total resistance is 6 ohms. Current will be
2 amperes.
2 amperes. So what will be the potential? The current would be 2 amperes like this. How will the current divide? The current will divide in inverse ratio. Yes or no?
Yes, sir.
So the current in this one will be 2 into
2,
3 divided by 9.
yes,
Current in this branch will be
2
2
into
into
6
6
divided by.
divided by 9. You can also find the potential drop. This is 4 ohms and the current is 2 amperes. So potential drop is 8 here and potential drop across this would be 4 here. Yes or no?
Yes, sir.
And the potential drop will be same because they are in parallel. So this is 4/3 and this is 4/6. You can get the answer in that way also. Do we understand what I am saying?
Yes, sir.
So there are many ways in which you can do questions like this, and these are the questions that are coming in JEE. and I've got too many papers that I cannot have a look at one go because they are not segregated topic wise. Again, no matter what question you do, you end up with the same result. What is the potential drop across the 10 ohm resistor? This is from JEE 2021 somewhere. How are you supposed to get this? You can find the effective resistance of this 50 and 20 in parallel. 50 and 20 in parallel becomes how much?
100 by 7, sir.
100 by 7. So this is 10 ohms and this is 100 by 7 and this is 170 volt. Voltage will divide in direct ratio. So voltage drop across this will be 170 into 10 divided by 10 plus
170
100 by 7. Yes or no?
is 170 by 7, sir.
So it is 170 by 7,
70.
70 you will get. So this will be 70 volt and this would be 100 volt. Do we understand this or this has gone above our head saying bye bye?
Understood, sir.
One more. Sometimes the internal resistance of the cell is also given. Don't worry, you just have to add it as one more resistance. Do we know this?
Yes, sir.
Again, 21 or 22 JE. Give you a minute to do it. So how are we supposed to do this? 3, 3, 3. All these three are in
1,
parallel. It becomes 1. 1, 5,
6 and 1, 7.
7. 21 divided by 7, 3. Answer is 3. See, these are the questions that are asked in a JE. Anyways, one more here. I think you can put it here. This one. When the condition given, switches S1 and S2 are in open condition, the resistance across AB when the switches S1 and S2 are closed is how much?
Sir, 10 ohms, sir.
12 and 6 are in parallel, 4 and 4 are in parallel, 12 and 6 are in parallel, and that is your answer. 4 plus 4 plus 2. Answer is 10. Yes or no?
Yes, sir.
So as you can see, things are very simple. Anyways, these were the questions from previous year JEE as well as the question on a single cell. Now, if there are more than one cell, then you have to use something else. If there are more than one cells and if there are more than one cells in more than one circuit, there are more than one loops. Now, up till now, we had different loops, but we only had one battery. As long as there's only one battery, you can solve it by series parallel combination, no problem. The problem comes when you have more than one battery in the circuit. If you have more than one battery in the circuit, how are you going to solve it? You're going to solve it by Kirchhoff's law. And what are those Kirchhoff's law? We are supposed to deal with two types of Kirchhoff law. What are the two types of Kirchhoff law?
Potential across a closed loop is summation of potential across closed loop is zero.
The first law is known as the Kirchhoff's current law or junction law or charge law. Kirchhoff's junction law, or you can call it Kirchhoff's charge law. You can also call it Kirchhoff's current law. What is this Kirchhoff's junction law, Kirchhoff's charge law, Kirchhoff's current law? This is the junction that you are seeing. What is this? What is happening here? This is the junction that you are seeing here. Some current or some charges are incoming. Some charges or some current are outgoing. What does this Kirchhoff junction law or
Current,
Kirchhoff charge law or
current
Kirchhoff's
incoming
current law
equals to
states
current incoming equals to current outgoing.
outgoing current are I1 and I5, I2 plus I3 plus I4. This is Kirchhoff junction law or Kirchhoff's current law or Kirchhoff's voltage law. The sum of current coming in a junction, incoming current, is equal to outgoing current. Do we understand this?
Yes, sir.
Incoming current is equal to outgoing current, and this law is based on the law of conservation of charge. So instead of current, we can apply it for charge as well. So you can say that Q3 charge is flowing like this, Q2 charge is flowing like this, Q1 charge, Q4 charge, and Q5 charge. So basically the original way of writing it is like this: Q1 clip plus Q5 will be equal to Q2 plus Q3 plus Q4. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Well, in this diagram that is drawn, you have to tell me what is the value of I. I'll give you 2 minutes. The value of I here will be 23 amperes. That is correct. How did you get it? If you can see, this is just a junction, but this junction has got 2 or 3 different points. Whatever is incoming on this entire junction, you can do it anyways. You can treat this entire thing as one junction. Do we understand this? This entire thing is one junction. Do we understand this?
Yes, sir.
The incoming current is 16, 15, 3 and 5. Yes or no?
Yes, sir.
Whatever current has come in, the same current has to go out. Yes or no?
Yes, sir.
So the current which is going out would also be 23 amperes. Do we understand this, or this has gone above our head saying bye bye?
Yes, sir.
Shall we move on to the next one?
Yes, sir.
The second law is known as Kirchhoff's voltage law or Kirchhoff's loop law, because normally it is applied in a loop. Kirchhoff's voltage law or loop law. What does this Kirchhoff's voltage law or loop law states?
Sum of the voltages in a closed loop is equals to zero.
So this Kirchhoff voltage law or Kirchhoff's Ohm's law or Kirchhoff's loop law states that the algebraic sum of all potential drops and all EMFs in a circuit closed loop is zero. That means summation of voltage drop is equal to zero, or this basically says that in a closed loop the change in potential is zero, or it says that in a closed loop E dot dl, which is the change in potential, is equal to zero. Do we understand this? If I move in a loop, in a closed loop, the sum of potential drop and EMFs of batteries and potential drop across various elements of a circuit, it would be equal to zero. Do we understand this?
Yes, sir.
Have you written this?
Yes, sir.
Now, whenever you apply this Kirchhoff's law, you will have to apply a sign convention. Sign convention. You have to apply it using a sign convention. And what is the basic premise of this sign convention? Potential rise. Potential rise is taken as positive and potential drop is taken as negative. Potential rise is taken as positive if the potential is increasing, is taken as positive. Potential is dropping, it is taken as negative. Potential rise is taken as positive, potential drop is taken as negative. Now, whenever we are traversing a loop, different types of different types of different types of circuit elements will come. Different types of circuit elements will come. The first circuit element that we are going to see is the resistance. The first circuit element that we are going to see is a resistance. And what happens? In case of a resistance, now we will go across the resistor. So basically we will be moving across the resistor, and in moving across the resistor we will undergo a potential rise or a potential drop. If we are moving in the direction of current, we would be moving from a point of where to where? If you are moving in the direction of current, you are
High to
moving
low,
from
sir.
where to where? If you are moving in the direction of current, you are moving from where to where?
High potential to low potential.
You are moving from high potential to lower potential, and therefore potential drops. So, if you are moving like this from point A to point B, if you're moving like this from point A to point B, and at the same time your current is also going in the same direction, green is the direction of current and pink is the direction of your motion, you are moving. So you are moving from a point A to point B. What will happen? What will be the relation between potential at A and potential at B? Which potential will be higher, A or B?
A, sir.
A will be higher. If I have to write the equation from A to B, how will I write it? I will write it as like this. VA is the potential of point A. I am at point A. I am moving from A to B. I am moving in the direction of current. So the potential will drop. Drop is taken as negative IR, because V is equal to IR is the only thing that we know about this. Do we understand this? So
Yes, sir.
VA minus IR, potential has dropped, and then I reach point B. So this is how the equation of this will look like. VA minus IR will be equal to VB, or you can write VA minus VB is equal to IR. Do we understand how I've written this?
Yes, sir.
Now, the same thing, I can, instead of moving from A to B, I can move from B to A. The current, as you can see, is moving in this direction, but I am now moving in this direction. Do we understand this?
Yes, sir.
That means I am now moving from point B to point A. Yes or no?
Yes, sir.
I am moving opposite to the direction of current. So is the potential going to rise or is the potential going to drop?
Rise, sir.
So I start from point B because I'm moving from B to A. So now I can write the equation like this: VB, and I'm moving opposite to the direction of current. So plus IR will be equal to VA. If I just transpose the equation, I will get the same equation as in the previous case. That means it does not matter whether I am moving from A to B or I am moving from B to A. The equation remains same. Do we understand this?
Yes, sir.
Or it has gone above our head saying bye bye.
Understood, sir.
I'll give you 2 minutes to note this down. Then comes the sign convention for battery. Now, for battery, it does not matter how the current is moving. The current may be moving here. The current may be moving in the opposite direction. It only depends on from where to where you are moving. Now, you can see here, if you are moving from positive terminal to negative terminal, if you are moving from positive to negative, from where to where you are moving? If you are moving from positive terminal of the battery towards the negative terminal, from where to where you are moving?
High potential to low potential.
So if I'm moving from point A will be at a higher potential. So higher potential, so you are moving from higher to lower, potential will rise or potential will drop.
Potential will drop, sir.
So that's why I take it as minus E. That will be equal to VB. So VA minus VB here will be equal to E. Do we understand this?
Yes, sir.
If by chance I move from B to A, from where to where I'm moving? I'm moving from negative terminal to the positive terminal. Yes or no?
Yes, sir.
If I move from negative terminal to positive terminal, will the potential rise or will the potential drop?
Potential rises, sir.
So if I move from B to A, the equation will look like this: VB plus E is equal to VA. No matter from where to where I move, if I understand whether it is a rise or a drop, the equation remains same. Do we understand this, or this has gone above our head saying bye bye? I'm going, don't worry about me.
Understood, sir.
You have 2 minutes to note this down. The next element that we are going to see is a capacitor. And again, in a capacitor, if you are moving from negative terminal to the positive terminal, from where to where you are moving?
Low potential to high potential.
So potential will rise. How much will be? It will be rising. It
Q by
will
C.
be plus Q by C is equal to VB. Here you will get VB minus VA as Q by C. Do we understand this?
Yes, sir.
If I move opposite direction, I move from B to A, I will move from a point of higher potential to lower potential. So the equation will look like this: VB minus Q by C is equal to VA. No matter how I write the equation, VB and VA are the potential of point B and A. The equation will always be same whether I move from A to B or B to A. Give you 2 minutes to note this down. Okay, so I think we have understood how to apply this equation, how to use the sign convention. I'm looking for a question if I can get it. Okay, I'm not able to get it, so I will make it.
Sir, once can you show the slide of inductor, sir?
Oh, we have not done inductor?
Yes, sir.
Oh, sorry, I forgot it. Forgot it. I was too engrossed with the question, I forgot it. Okay, so inductor, the third element of this is inductor, and inductor, the potential is same as your resistor if you are moving in the direction of current. As you can see, you are moving like this, and the direction of current is like this. In the direction of current, potential drops, and it is taken as negative because it is dropping L di by dt. That is how it is given. So if you write the equation from A to B, in the direction of current, it will be looking like this. If you are moving opposite to the direction of current, you are moving like this, and current is going from this. So you write the equation from B to A. In that case, it will be treated as a rise opposite to the direction of current, because this potential drop across the inductor depends on the current. Therefore, you have to take it from the current. So in that case, it will be looking like this. Do we understand this?
Yes, sir.
So this inductor, the sign convention for inductor is same as sign convention for the resistor. The sign convention for the capacitor is same as the sign convention for the battery. Do we understand what I'm saying here?
Yes, sir.
I'll give you 2 minutes to note this down. Then this is the next question. You have to find VA minus VB in this particular case. I'll give you 2 minutes to give me the answer. Oh, sorry, in this I have not given you the current. Current is flowing from here to here. Sorry, I did not give you current. And the value of current is 5 ampere. Current is flowing from here to here. Did not give you the value of current. Sorry. Now solve this question. So how are we supposed to do this? Let me start from A to B. So I will be going like this. As you can see, current is coming like this. Doesn't matter. So I start from point A. I call the potential of point A as VA. The first thing that I do is I go across this battery. From where to where? I am moving across
Low,
this battery.
high to low, sir.
I am moving from positive to the negative terminal. This is the positive terminal and this is the negative terminal. I am moving from high to low. So potential will rise or drop?
Drop, sir.
-2. Do we understand how I have done this?
Yes, sir.
Then I move across this resistor. I am moving like this, but the current is going like this. Rise or drop?
Rises, sir.
Rises. So it will be plus 4 into 5. Do we understand this?
Yes, sir.
Then I move across this battery, the blue one, the next blue one. And you can see I'm moving from negative to the positive terminal. So will it rise or will it drop?
Rise, sir.
How much will it rise?
3 volts.
+3. Is everyone able to follow me or we are going bye bye?
Able to follow you.
Bye bye.
No, sir.
Then I move across the resistor. I must remember that I am moving like this, but the current is going in that direction. Rise or drop?
Rise, sir.
How much is the rise?
2 into 5.
+2 into 5. And where do I reach now?
VB.
I reach point B. From here, I should be able to calculate the value of VA minus VB. Do we understand this?
Yes, sir.
Or it has gone above our head saying bye bye?
Understood, sir.
Bye bye.
No, sir.
Okay. And the same thing, let me give one more question. This is A, this is B. This is 2 volt, this is 3 volt. This is 2 microfarad. This is 3 microfarad. The charge on this one, this is the positive terminal and this is the negative terminal. This is the negative terminal and this is the positive terminal. It is given to you. The charge on this one is 8 microcoulomb and the charge on this one is 9 microcoulomb. You have to find out VA minus VB. Can you do this?
Yes, sir.
2 minutes to give me the answer. So how are we supposed to do this? I will be moving like this from A to B. Start from point A. Potential is VA. Then I will move across the battery. Is it a rise or is it a drop?
Drop, sir.
How much is the drop?
2 volts.
So it is -2. Then I move across this green capacitor. Is it a rise or is it a drop?
Drop, sir.
How much?
4.
Drop means negative. -4. Are we able to understand or this is going above and it's saying bye bye?
Understood, sir.
Then I move across this. Rise or drop?
Rise, sir.
How much rise?
3.
Do we understand this or bye bye?
Understood, sir.
Then I move across the battery. Rise or drop?
Rise, sir.
How much rise?
3 volts.
That should be equal to VB. From here you can calculate VA minus VB and you end up with the answer. And the answer is
0.
0. Hero, my dear friend. 0, hero, my dear friends. Do we understand this or this is going above or it's saying bye bye?
Understood, sir.
This is one question that I just saw. It got nothing to do with what we're discussing, but just here to show you how questions are framed in a JEE these days. It's 2019. The figure shown below, the charge on the left plate of the 10 microfarad capacitor is -30. What is the charge on the right plate of the 6 microfarad capacitor? I'll give you a minute. This is an oral question. So, how are you going to do this? On this plate we have minus sign and this plate we have plus. Yes or no?
Yes, sir.
This is 30 microcoulomb. Yes or no? So
Yes.
this plate will get negative and this plate will get positive. This plate will get negative. This plate will get positive. This plate will get negative and this plate will get positive. Do we understand this or this is gone above or saying bye bye?
Understood, sir.
Bye bye. How does charge divide in? These are two capacitors in parallel. How does charge divide in parallel capacitors?
Inverse.
It divides in direct ratio. Divides in direct ratio. It 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 divides in direct ratio. So the charge on this one would be 18 microcoulomb and charge on this one will be 12 microcoulomb. How did I get this 18? This charge on the 6 microcoulomb microfarad capacitor will be 30 into 6 divided by 6 plus 4. So the answer for this one, my dear friend, is plus 18 microcoulomb. I'll give you a minute to note this down. Now we will try to apply this Kirchhoff voltage law in a closed loop or a closed circuit. Now how are we going to apply? Instead of writing the steps, which is of no use, what are we going to do is we are going to see how we are going to apply. So, and I'm going to apply it in same way in all the cases. I will choose one point on the loop Normally I choose the leftmost bottom point. And then I will move in the clockwise direction in this loop. I always move like this. You can move in the anti-clockwise direction, but I always choose this direction. And then I will start to give current, and again in the same direction I give current. If my answer comes positive, my direction is correct. If my answer comes negative, my direction is wrong. So I say that I current is flowing, and since there is only one loop, there is only one current, I have to get the value of I. How do I get the value of I? Using Kirchhoff's law. So I start from point A and I will move in the circuit in this direction, which is shown by the direction of the loop. Do we understand this? I will
Yes, sir.
move in this direction and I will apply Kirchhoff's law. So I start from point A. So I call the potential of point A as VA. The first thing that I will move across is what?
R1.
Will it be a rise of potential or drop of potential?
Drop, sir.
How much is the drop?
I R1.
Minus I into R1. Then I will move across what?
Battery E1.
Battery E1. Rise or drop?
Rise, sir.
How much is the rise?
E1.
Plus E1. Do we understand this or this is going above or it's saying bye bye?
Understood, sir.
Then I will go across the resistor. Rise or drop?
Drop, sir.
How much?
I R2.
Minus I into R2. Then I will move across the battery E2. Rise or drop?
Rise, sir.
How much?
E2.
Plus E2. Then I will move across the resistor R3. Rise or drop?
Drop, sir.
How much?
I R3.
Minus I into R3. Then I will move across this battery E3. Rise or drop?
Drop E3, sir.
Drop means minus E3. Then I will move across the resistor R4. Rise or drop?
Drop, sir.
Then I reach which point? I reach the point A again, so I can write it as VA. This will get cancelled actually. From here you can get the value of I. I will be equal to E1 plus E2 minus E3 divided by R1 plus R2 plus R3. You don't have to write R1, all these equations like this. Once you understand that current is same, you can just add up all the resistance together. Do we understand this or this has gone above or it's saying bye bye?
Understood, sir.
If your value of I comes positive, that means the direction was clockwise. If it was I1 plus I2 is less than I3, sorry, E1 plus E2 is less than E3, it will come negative. In that case, the direction is not clockwise, but it would be anti-clockwise. Do we understand this or this has gone above our heads? Saying bye bye, bye bye sir, I'm going, bye bye sir, I'm going, bye bye sir, I'm going.
Understood, sir.
Thank God, sir, because now question coming for you, sir. Eh? This is the question and you have 2 minutes to give me the answer. So I will choose point A and I will move like this. I understand that all the resistance will be added up and I will allow current like this. Yes or no?
Yes,
Will
sir.
just flow current like this and I will move in this direction. So the value of current I will be equal to how much? 10 would be positive,
Yes, sir. Minus 20.
20 would be negative,
15 positive.
15 would be positive,
30 is
and
negative.
30 would be negative divided by how much is this? 3 plus 2 plus 1 plus 4. So I think that is your answer. And I think current is coming in the anti-clockwise sense. Do we understand this? Yes or no?
Understood, sir.
Everyone understands this?
Yes, sir.
Okay. Now, similar to Kirchhoff's law for resistance, you can have KVL for capacitance as well. You can make any random circuit with any random number of capacitors, and I'm making a circuit similar to what we had drawn. Remember, all the capacitors are initially uncharged. All the capacitors are initially uncharged. Remember this. All the capacitors are initially uncharged. So I have made 3 batteries and I think 4 capacitors. Then again I will choose a point A and I will move like this and I will say Q current, Q charge flow. So this will be positive and this will be negative. Do we understand this?
Yes, sir.
Because Q charge is flowing like this. So this will be positive and this will be negative. All the capacitor will get same charge. Do we understand this?
Yes, sir.
This will be positive, this will be negative. The charge will flow like this will be positive and this will be negative. Now I can apply Kirchhoff's voltage law here. How will I apply Kirchhoff's voltage law? I will start from the point A. What is the first thing that I see? VA, and then I will move across the capacitor. Yes or no?
Yes, sir.
Positive or negative?
Negative, sir.
Negative Q by C1. Then I will move across the battery. Positive or negative?
Positive, sir.
Plus E1. Then I will move across the capacitor. Positive or negative?
Negative, sir.
Then I will move across the battery. Positive or negative?
Negative, sir.
Negative E2. Then I will move across the capacitor. Positive or negative? Will be negative. Then I move across the battery. Then I move across the capacitor and I come to the same point. From here, I should be able to calculate the value of the charge Q. Yes or no?
Yes, sir.
Give you 2 minutes to note this down.
Done, sir.
Then you have this question. You have to find the charge coming on. Initially, both the capacitors are uncharged. You have to find out. Initially, both the capacitors are uncharged. You have to find out the charge on the capacitors if they are connected in this fashion. Do we understand this? How we have to do this?
Yes, sir.
I'll give you 2 minutes to do it. So how are we supposed to do this? Let me start from this point A and I will move like this and I assume that the charge is flowing like this. So this will get positive and this will get negative. This will get positive and this will get negative. Yes or no?
Yes, sir.
I can now apply Kirchhoff's law starting from point A, VA plus 2V. Yes or no?
Yes, sir.
Minus Q by 3 plus, oh, plus or minus? Battery
Minus, sir.
minus 5 minus Q by 6 will be equal to VA. Do we understand this? From
Yes.
here you are going to get the value of VA. How much you are getting the value of V?
3 by 2, sir.
Hmm?
Minus 3 by 2.
Minus 3 by 2. That means my distribution is wrong. Whatever I assume as positive plate, that was not positive, it was actually negative. Do we understand this?
Yes, sir.
So positive plate actually is negative plate and negative plate actually is positive plate. Do we understand this?
Yes, sir.
Yes or no? Do we understand this? Yes or no?
Understood, sir.
Next, in this capacitor circuits, you may have question where they ask you heat developed in the wire. So you can write this concept. Energy equation. Energy equation for capacitors. Energy equation for capacitors. What is this energy equation for capacitors? Now, the up till now, what we were dealing with were capacitors which were initially uncharged. But now we might be dealing with cases where capacitors are initially charged. So if you are dealing with cases where capacitors are initially charged, then you might have to take their initial energies into account. So UI means the initial energy stored in all the capacitors together. Do we understand this?
Yes, sir.
Plus, there could be a battery connected to the capacitor. So plus work done by battery, plus there might be external forces acting on the system to do some work. So work done by those external forces, that will be equal to U final plus delta Q or delta H. This delta Q or delta H will be the amount of heat which would be liberated out when the capacitors are connected to each other. Do we understand this?
Yes, sir.
So this is the equation of energy that you will have to remember for any question that comes in this category. And we'll start with this question from SCV so that we understand the concept that we are supposed to do. So this is the question. A 5 microfarad capacitor is charged to 12 volt. The positive plate of this capacitor is now connected to the negative terminal of a 12 volt battery and vice versa. Calculate the heat developed in the wires. I'll give you a minute to think about this. So how are we supposed to do this? This is the first case scenario when let me call this plate as A and let me call this plate as B. This is the positive and this is the negative terminal of the battery. This is the initial case. This is the initial case. This battery is 12 volt. So basically what is going to happen is this plate will get positive charge and this plate will get negative charge. How much positive and how much negative? 60 microcoulombs. Plate A is positively charged. Plate B is negatively charged. Now I come to the second case. In second case, what has happened is positive terminal of this is connected to the negative terminal and vice versa. So the battery has been reversed. This is the negative terminal. This is the positive terminal. 12 volts battery. This is A. This is B. Now what will happen is this plate will get positively charged and this plate will get negatively charged. The charge is again same because the battery has not changed. We have to find out the heat developed in this wire. This was the initial configuration and now the configuration has changed like this. I will just apply the equation, the energy equation of capacitor Ui plus work done by battery plus work done by external forces will be equal to UF plus heat. Now, since the charge battery is same, the charge is same, the initial and the final energies are same, so they will cancel each other out. Yes or no?
Yes, sir.
Here there is no external force coming, so work done by the external force is zero. Yes or no?
Yes, sir.
So the heat developed is nothing but equal to the work done by the battery. Yes or no?
Yes, sir.
So heat developed is equal to work done by the battery, work done by the battery.
Q square by C, sir.
Work done by the battery is charge Q, the charge which has flown multiplied by the EMF of the battery. Yes or no?
Yes, sir.
Now how much charge has flown through the battery? That is what you have to find out. How much charge has flown through the battery? How much charge has flown through the battery? That is what you need to find out. So you look at any one of the plates. You look at plate B, let us say. Plate B was having negative charge. Now it has positive charge. It was having negative 60 coulomb charge. Now it has positive 60 coulomb charge. So how much charge has flown from where to where?
120.
120 plus 120 coulombs has flown in this direction. Yes or no?
Yes, sir.
Plus 120 coulomb has flown like this. Yes or no?
Yes, sir.
Plus 120 coulomb has flown in this direction. Yes or no? Is the work done by the battery positive or negative? 120 coulomb has flown like this. Is the work done by the battery positive or negative?
Positive, sir.
And that is equal to the heat developed in the wires. So plus 120 microcoulomb multiplied by 12 plus 144 microjoules. That is the energy given out in the form of heat. Do we understand this? How this is done?
Yes, sir.
Yes or no? Do we understand how this is done? Yes or no?
Yes, sir.
Have you noted this down?
1 minute, sir.
Then we have this question. A capacitor having capacitance of 100 microfarad is charged through potential difference of 12 volt. The charging battery is disconnected and the capacitor is connected to another battery of EMF 12 volt. The positive terminal of the capacitor is connected to the positive terminal of the battery. Then you have to find out everything before and after. Same question. Here the battery is not same and it is connected in the same sense. I hope you understand the question. Yes or no?
Yes, sir.
I'll give you 2 minutes to give me the answer for this.
C, D, and E.
Okay, so how are you supposed to do this? First case, the capacitor is connected like this. 12 volt battery. This is the positive and this is the negative.
Sir, first 24, sir.
First is 24. So it will have charge 2400 micro coulomb. Yes or no?
Yes, sir.
Then it is changed The positive is connected to positive, so it becomes like this, 12 volt. This is plus, this is minus. It now becomes 1200 microcoulomb. So the first part is already known to you. You know, find the charges before and after the connection. The answer is already there. That is the first part of the question. The second part of the question is find the charge which has flown through the battery. How much charge has flown through the battery? You look at any one of the terminals and you see how much charge has flown to the battery. How much charge has flown to the battery? This one was plus 2400. This one has become now plus 1200. So how much charge has flown? Plus 1200 charge has flown like this. Plus 1200 charge has flown like this from here to here. Plus 1200 charge has flown like this. What is the work done by the battery? It's the work done by the battery or it is work done on the battery?
Work done on the battery.
Work done on the battery and therefore it is negative. So negative 1200 multiplied by 12, that is the work done on the battery or work done by the battery, it is negative. Find the decrease in electrostatic potential energy. You know the initial electrostatic potential energy, yes or no? You can find it out by V square by half CV square, or you can find it out as Q square by C 2C. Doesn't matter. You know the initial energy. You also know the final energy, yes or no?
Yes, sir.
Then you can find out the heat developed in the wires, UI plus work done by battery plus work done by external forces, that will be equal to U final plus the heat developed. How much is the initial energy? You already know it, yes or no?
Yes, sir.
How much is the final energy? You already know, yes or no?
Yes, sir.
Work done by the external force is 0. Work done by the battery is already given here. So from there you can calculate the heat developed in the wires. Am I clear?
Yes, sir.
So this is the way this question is done. Do we understand this?
Yes, sir.
Now we have the third category of question where you have two capacitors which are charged and connected to each other. Have you done this question?
Yes, sir.
Then this is the next one. A capacitor of capacitance 5 microfarad is connected to 12 volt battery. Another capacitor of capacitance 5 microfarad is charged to 12 volt. Find the energy stored in each capacitor. The positive plate of the first capacitor is now connected to the negative plate of the second and vice versa. Find the new charges and find the loss in potential energy. I'll give you 2 minutes to give me the answer for this one. Now, how are we supposed to do a question of this nature? So basically, you have two capacitors and then these two capacitors would be connected to each other via some switch. So let me make a switch as well. This is the 5 microfarad capacitor here. It is charged to 12 volt. So let me assume that this is the positive plate and this is the negative plate. This is 5 microfarad capacitor. The charge on this capacitor will be 5 multiplied by 24. How much is 5 multiplied by 24?
120, sir.
120. Okay, so this is your pink capacitor. This is your pink capacitor. Now the other capacitor, let me call it as the green capacitor, 6 microfarad. charge to 12 volt. The negative of the first is connected to the positive of the second. So let me call this as negative and let me call this as positive. Do we understand this?
Yes, sir.
This is your 6 microfarad capacitor and the charge on this capacitor is 72. Yes or no?
Yes, sir.
This is the initial condition. This is the initial condition. You have the green capacitor and you have the pink capacitor. This is the initial condition. Now, when the switch is closed, let us assume that this is the final condition of the capacitors. I assume that this is the positive plate, this is the negative plate, then this will be the positive plate and this will be the negative plate. This is my assumption. Do we understand this?
Yes, sir.
I assume that this plate has got plus Q charge, so this plate will get minus Q. Do we understand this?
Yes, sir.
Okay. Now remember, the capacitors were not initially uncharged, so the next plate will not have plus Q charge. To find out the charge on this plate, what you have to do is, you'll have to apply that the charge of a system remains constant. Now, if you take these two plates as one system, you look at the initial charge on these two plates together. What was the initial charge on these two plates? The right plates together. What was the initial charge?
182.
Take a deep breath. Open your eyes and then tell me the answer.
192.
Relax. Deep breaths. Relax. Close your eyes. Slowly open them. Look at what you see on the board and then tell me the answer. This is minus and this is plus. So the total charge on these two plates is minus 48. Minus 48. Out of this minus 48, minus Q has come here. So minus 48 is the total charge before. So after connection, the total charge has to be minus 48. Minus Q has already come here. I've taken this plate as positive. Minus Q has already come on first plate. So the charge on the other plate will be minus 48 plus Q. Do we understand this?
Yes, sir.
And on the other plate, it will be minus of minus 48 plus Q. Do we understand this?
Yes, sir.
Everyone understands this? Now I can apply the Kirchhoff law from point A to B, from point A to A, and write it. From there, you will get the charges on the plate. See, VA. Then I move across this capacitor. I am moving from the positive to the negative plate. Do we understand this?
Yes, sir.
So it will be minus Q by 5. Do we understand this?
Yes, sir.
Then again, I am moving from the positive plate to the negative plate. So again, it is minus of minus 48 plus Q divided by 6, that will be equal to VA. Do we understand this?
Yes, sir.
From there, you can find out the value of Q. Once you get the value of Q, you will know the final charges on the each capacitor. From there, you can find out the final energies. And from there, you can find out the heat developed by the formula that I have given. Do we understand this?
Yes, sir.
So this is how you can solve any question of this type. I'll give you one question for practice. I'll give you 2 minutes to tell me the answer for this one and solve it. Then you can do this question. Here I have two capacitors. The first one is having capacitance C. It is charged to a voltage V. The second one is a capacitor of capacitance 2C and it is charged to voltage 2V. V and 2V are the voltages. Do we understand this?
Yes, sir.
Then they are connected in this fashion. The positive plate of one capacitor is connected to the negative plate. You have to find out the total charge. Find out the final charge on each capacitor. Once you get the value of final charge, you can find out the other things. Yes or no?
Yes, sir.
Okay.
CV
Yes.
C into V on each. Uh, C into V on top charges and
So how are we supposed to do this? This is the initial circuit and I will draw the final circuit. This is the final circuit that I have drawn. I don't know what are the charges. So let me call this as positive. Let me call this as negative. Let me call this as positive. Let me call this as negative. So this is plus Q. This will be minus Q. This will be plus of what is the initial charge on these plates? Two of these two plates together. Initial charge is 3 CV. Yes or no?
yes, sir.
So final charge has to be 3 CV. Minus Q has already come there. So on this plate it will be 3 CV plus Q. Do we understand this?
Yes, sir.
And on the other plate it will be minus of 3 CV plus Q. Do we understand this?
Yes,
And
sir.
now I can move in the circuit and I can write the equation VA minus Q by C minus 3 CV plus Q by 2C, that must be equal to VA. From here I will get the value of Q. What is the value of Q I'm getting here from here?
CV, sir.
Q is equal to CV. So the charge on the first capacitor is CV and from there you can find out the charge on the other capacitor. Yes or no?
Yes, sir.
Everyone got this?
Yes, sir.
Are you sure it is coming 3 CV? CV?
Yes, sir.
I don't think so. You have done some mistake, I think. If I put the value of CV there, it's not coming. 5 by 2 cannot be. It's not coming CV. It will not be CV. I don't know how you get it. Anyway, I think you can get this one, get your answer and stay happy. You should be able to solve this. If you're not able to solve this, I can't help you much here. Right? I don't think it is coming as CV. Cannot come as CV from here. Anyways, I think you can solve this. I will have to move ahead in life. Now let us move on to the next type of questions. In the next type of question, what we are going to do is we are going to do questions based on connection of plates. Sometimes these questions come.
Sir, that is minus CV, sir.
What is minus CV, sir?
Q equals to minus.
Whatever, yeah, whatever. You can solve it, no?
Yes, sir.
Let's solve it. I'm not going to praise your calculation skills by solving this, or I'm not going to abuse you if you're not able to solve this. You have made the correct equation. That is my concern. You solve it or not, that is not my concern. If you can't solve this equation, I can't help you, right? No one can help you if you can't solve these questions, these equations. And if you solve them correctly, well, God help you. Only God can help you in that case. So I will not move much. I will move on to the next category of questions where we will see how do you solve question of this category. So questions on plates. Question on plates. What are these question on plates? In this question on plates, you will have 3 or 4 different plates, and these plates would be connected to some points. Let us say this plate is connected to point A. This plate is connect. Let me make it this way. These two plates are connected to point A. These two plates are connected to point B, and you are supposed to find out the capacitance of this system. It is given that the area of each plate is A, and the distance between any two plates is, let us say, given as D. So these are the informations given to you. How these plates are connected, that is given to you. The area of these plates is given to you, and the distance between the plates is given to you. And you would be asked to find out the capacitance of this system between points A and point B. How are you going to solve this question? How are you going to solve this particular question on plates? Yes. Any idea how are you going to solve this question on plates? So how are you going to solve it? You can call this plates by name. 1, 2, 3, 4. There are 4 plates here. These 4 plates make 4 capacitors. This is capacitor number 1, this is capacitor number 2, and this is capacitor number 3. The capacitance of all these 3 capacitors, see, the capacitance is same because the area of the plates is same and the distance between the plates is same. Do we understand this? So what we are going to do here is we are going to reconnect these plates and see how are they connected, and from there you will be able to find out the capacitance of this system. How are we going to find out the capacitance of this system? Let me start with point A. This is point A, and as you can see, plate number 1 is connected to point A. Plate number 1 is connected to point A, so I make this plate number 1, and I connect it to point A. Plate number 1 and plate number 2 make a capacitor. So I will make a capacitor here of plate number 1 and plate number 2. This capacitor is your blue capacitor. Now this plate number 2 is connected to point B also, as you can see. So I have connected it to point B. I have made the first capacitor and I have connected it correctly across the 2 terminals. Do we understand this?
Yes, sir.
Then let me move on to this green capacitor. This green capacitor is the capacitor which is made from plate 3 and from plate 2. Do we understand this? So I make this green capacitor. Plate number 2 is here, and plate number 3. Plate number 2 and plate number 3 make the green capacitor. But as you can see, plate number 3 is connected to point A. Yes or no?
Yes.
So I connect this plate to point A. I have made the green capacitor. The green capacitor is connected in this fashion. Do we understand this?
Yes.
Then I come to this yellow one. This yellow one is a capacitor between 3 and 4. Plate number 3 is connected to point A, and plate number 4 is connected to point B. This is your third capacitor. Do we understand this?
Yes, sir.
Do we understand this?
Yes, sir.
That means all the three capacitors are connected in how?
Parallel, sir.
They are connected in parallel, so the effective capacitance or equivalent capacitance becomes 3 times A epsilon naught by D. Do we understand this?
Yes, sir.
Everyone understand how these are connected? Yes or no? We are able to understand this?
Yes, sir.
Shall I give you the next question?
Yes, sir.
This is the next question. I'll give you 2 minutes. The area of the plates is A. Forget about area of the plates. You can call the capacitance between any two plates as C. So you can give your answer in terms of C. Do we understand this?
Yes, sir.
You have 2 minutes. So how are we supposed to do this? This is plate number 1. This is plate number 2. This is plate number 3. This is plate number 4. When I start drawing the circuit, starting from point A, plate number 2 is connected to point A. Plate number 2 and 1 make a capacitor. So this capacitor is the blue capacitor. 2 and 1. Do we understand this?
Yes, sir.
Now this plate number 1 is connected to plate number 3. So let me make plate number 3 over here. And 3 and 4 also make a capacitor. So 3 and 4 make a capacitor, and 4 is connected to point B. So this is your green capacitor 3 and 4. Do we understand this?
Yes, sir.
The only capacitor remains is capacitor between 2 and 3. Let me call this as the pink capacitor. So I need to connect this pink capacitor. How I'm going to connect this pink capacitor? 2 has to be connected to point A, 2, and 3 has to be connected to 3 only. So this is 3 connected to 3. This is the pink capacitor. The blue capacitor and the pink capacitor are in parallel, yes or no?
Yes, sir.
So it becomes C plus C, 2C. 2C and C are in series, so the final answer is 2C by 3. Do we understand this?
Yes, sir.
Everyone understands this, or this is gone above our head saying bye-bye?
Understood, sir.
Pakka?
Yes, sir.
This is the next one in this series. Now I have 5 plates, but that doesn't make any difference to the thing. You don't look at positive, negative. Between any two plates, you have capacitance C. You have to find the effective capacitance between points A and point B. I hope you understand this. Yes or no?
Yes, sir.
I'll give you 2 minutes to give me the answer. 3 by 5 epsilon naught A by G or 3 by 5 C. I think that is correct. How are we supposed to do this? Again, 1, 2, 3, 4, 5. 5 plates. I have 4 capacitors. I am going to connect them. Let me start from point A. Point A. Point A is connected to plate 3. 3. 3 and 4 make a capacitor. So 3 and 4. And I am done with this yellow whatever capacitor is this. Do we understand this?
Yes, sir.
Now 4 and 5 also make this pink capacitor. So let me make this pink capacitor. 4 and 5. 4 and 5 put together make this pink capacitor, and I see this is connected to point B. So I'm done with 2. I have to make the other 2. Let me make the other 2.
Other three, sir.
Other 2, 1 and 2. 1 and 2 make a capacitor. 1 is connected to point C. Where is point C? Point 4 is point C. Do we understand this?
Yes, sir.
So point 4 is point C. So let me connect 1 over here. 1 and 2 make a capacitor. So I make 1 and 2. 2 and 3 also make a capacitor. So I can make 2 here. I can make 3 here, and I can connect this to this point. Yes or no?
Yes, sir.
So this 2 and 3 is your blue capacitor, 2 and 3. This is your green capacitor, 1 and 2. Now the question becomes pretty simple and straightforward. These two are in series, so it becomes C by 2, yes or no?
Yes, sir.
Then they are in parallel, so it becomes C by 2 plus C, 3C by 2, yes or no?
Yes, sir.
Then they are in series, so I think it will become 3C by 5. So the final answer is 3C by 5. Do we understand this?
Yes, sir.
Last one for today, and this is the one. I'll give you 2 minutes to give me the answer. 2C, I think, is the correct answer. Let me call this as plate 1. Let me call this as plate 2. This is plate 3. This is plate 4. Now, let me make the capacitors. A. A is connected to 1. 1 and 2 make a capacitor. 2 is connected to point B. Yes or no?
Yes, sir.
So this is my pink capacitor here. Now remember this capacitor 2 and 3, both the plates are connected to the same point. So this does not make a capacitor. Do you understand this?
Yes, sir.
Why? Because both the plates are connected to the same point. We cannot connect it to the same point. So that is useless capacitor. So the only capacitor that remains is the green one. So let me make the green one. 3 is connected to point B. So I make 3 here. 4 is connected to point A. I make 4 here. 3 and 4 make one capacitor. These two capacitors, as you can see, are connected in parallel. Therefore, the effective capacitance becomes 2C. Do we understand this? Yes or no?
Yes, sir.
Well, that brings us to an end of this particular section. We are done with capacitor. We are done with circuits as such. We have not done with circuits which involve two loops. So we will be doing those circuits in tomorrow's class. These circuits are not coming these days, but still we have to do it because it's a part of your course. So first of all, probably we will do the part on dielectrics, then we will move on to those two loop circuits, and from there we will march on. So I'll see you in the next class. Up till here, everyone has understood?
Yes, sir.
Are you trying the exercises and the sheet that I have sent you? Have you started doing them?
Yes, sir.
Okay, then wishing you all the best, and I hope that you can perform much better in the next session that is coming up. And please check your answers and let me know the result as well. Take care. God bless you all. Bye bye.
Bye, sir. Have a good day, sir.
Bye, beta. Same to you.